Let's do some algebraic applications using the triangle sum theorem and the exterior angle theorem. So you want to copy this picture in your notebook. So let's start solving. So we're going to solve for, I guess x first would be the best case, right? Because if I look here, I have this right triangle. So I could pull up my highlighter. There's a highlighter, right? Here's my right triangle. And I know that the sum of the interior angles is 180. So if one of the angles is 90 already, that means x plus 40 has to equal 90. Therefore, x is 50. Okay, now, there's a couple ways that you could go about getting y. And again, everybody sees these differently. I'm just going to, I'm going to use the exterior angle theorem. You may not see it like that, but that's okay. But what I notice here is in this triangle, okay, I have this triangle. If I extend this one side of the triangle and I get my exterior angle, this exterior angle is 121 degrees. That means that 2y plus 55 equals 121 degrees, right? Because that's what the exterior angle theorem states, is the two non-adjacent interior angles is equal to the sum of that exterior angle. So we would get 2y is equal to 66, so y equals 33. Now, if you didn't catch on to what I just did in the first example using the exterior angle theorem, I figured I'd throw this one in here so you could see how a basic exterior angle theorem problem looks. So here, I have my triangle and I extend one side of the triangle. When you extend one side of the triangle, you create that exterior angle. The exterior angle, which is 2x minus 5, is equal to the sum of the two non-adjacent interior angles. So solving this, we get x equals 75. Okay, that's a basic exterior angle theorem problem. Now this is a great example because it incorporates what we just talked about last chapter. You'll notice that in this figure we have parallel lines. And I like to highlight over my parallels, so let's highlight that in red there, in red there. There's my two parallels, right? And bringing up my highlighter, as I like to do with when we talk about parallel lines, here's my x, angle marked as x. Well, you'll notice there's my other parallel. Zoom down, we made a z, right? Alternate interior angles. So, boom, boom, boom. This angle and this angle are congruent. So I could put x right in for that angle. I also know if this is a right angle, these lines are perpendicular, which means all the way around I have right angles. So now this is a right triangle, and this is a right triangle. So in this right triangle, one of the angles is 30. Therefore, the other acute angle is the complement of 30, which would be 60. So I could put 60 in for that x there. All right. You could also do going the other direction. If I bring up, let's say, a green highlighter, okay? If I trace out my y, follow down the transversal and up, you would see that the angle marked as 30 degrees, that one we were just talking about, is actually alternate interior with y. So y is 30. Okay? You could have gotten that way, or you could have used the sum of the angles of the triangle, but either way, we still get the x value is 60, y value is 30. Now, our last example, we have triangles inside of triangles. So copy this picture down. It's best always, anytime you're doing these problems, copy the picture down. And then we're going to analyze what we have. Alright, so I'm actually not going to go in like the alphabetical order of x and y. I'm just going to go with what I see. And the first thing that I actually see in this picture is this right triangle. Okay? If I look at that right triangle, let's take it to the side. Ooh, isn't that cool? Ooh, that's so cool. Okay, so if I take that to the side, here is my right angle of the triangle. This angle was marked as 32 degrees, that guy right there, and this is y. Now we could actually see how we would solve this, right? Well, we know that those angles are complementary. Those acute angles are complementary. So we're just going to do 90 minus 32. So y is 58 degrees. So I could put 58 right there. All right. Now, the other thing I see, if I bring out my highlighter again, let's do blue. So if I look at this triangle right here, boom, boom, boom. We don't necessarily know it's a right triangle. And again, many ways to do this, but I want to use the theorems we've talked about. If I extend this side of the triangle, I find my angle marked as x. Okay, here's my exterior angle marked as x. The exterior angle is equal to the sum of the two non-adjacent interior angles. So all I have to do to get x is say 27 plus 58, and x equals 85 degrees. Now, another way that we might have been able to do this was use your triangle sum theorem and use the fact that this angle here and x are a linear pair. It does not matter. We end up with the same answer, but I'm just trying to get you to see how to use the exterior angle theorem that may not be so obvious. Okay? All right, talk to you later.